This video continues from the previous video. Okay, so there are also recommended insulation levels that you can refer to. And this chart shows you that for 3, which is central Georgia, most of Georgia, that the attic, down here on the orange, the attic should be R30 to R60. What to do with the cathedral ceiling, put 13 to 15 in a wall cavity, and R25 in the floor. And on the right, you'll see just some different compositions of what you can do to get that R value. There are code books that show the different potentials for achieving an R value. And so you can see over here, for instance, so it says for zone 3, you want R13 to R15 in the wall. In this wall construction over here, wall 9, that is R14. But the problem is, you can see, is that they use 2x6s, and 2x4s are more common. But if we go to the same and we look at 2x4 above for wall 8, you can see it only has an R value of 10.5. So one of the things is you'll see is the reason to add siding, brick or wood siding to a house, because not only are you going to get another layer of insulation, but you're going to get a air gap between that wall and the brick if you use brick. And that air gap will help increase the R value. And then the brick will increase the R value. Brick houses are more expensive to build, but it can be said, it's arguable, that they save cost over the life of the building. Okay, and let's talk about vapor barriers above grade, which is where we now are. Foundation is below grade for the most part. Most of it is. Some of it sits above. So we were using a vapor barrier to keep out the water. But the problem with vapor barriers above grade, especially in the South, is that it can do damage. If you install vapor barrier either on the wrong side or in the wrong climate and wear the wrong climate, it can cause the water vapor to get trapped inside so it doesn't leak out. And then it can create mold, it can cause rot, it can create a whole bunch of issues. And showing you an example. And so what ends up happening, how the vapor gets inside the wall, is this. We have something called dew point. And dew point is the temperature at which the vapor in the air becomes condensation. And we've all seen it on windows. Like in the winter, we'll get condensation, or summer, we'll get condensation on one side or the other of a window or a glass door based on the dew point hitting, so that the condensation forms on that surface. And it can happen inside of a wall. So if the dew point happens to hit so that the vapor turns into condensation, and the condensation builds and begins to either run down the wall or freeze or something, it can create the damage as seen in the photo there. And so that's why we do not put vapor barriers in walls in the South. All right, so once we've built our wall out of wood studs and we have put an outside layer of insulation, inside layer of insulation, we then get to the siding. And some of the common ways of finishing the house, adding additional R value, can be wood siding. I think that's beautiful. So I put that picture in there. There are all kinds of different forms of siding. Wood siding can be made out of a lot of different woods. Just kind of depends on the look you're going for. You can stain it. In fact, you should stain it. Seal it. There are also composition boards that mimic wood siding that are made out of wood, and cementitious fiber board that are more durable. Those can be integrally colored. I can never say that word. Integrally colored, so that they're permanent and the sun won't fade out that color. Wood is a lot of work because it is going to be exposed to the sun and the winter and the rain and the snow and all kinds of stuff attacking it. And so you have to protect it. There are certain paints that are like ceramic paints that will last for like 40 years before you have to repaint. But wood does require regular maintenance. It is why you see decks falling apart on the sides of houses all the time because people have not properly maintained them. And so here you can see an example of construction for wood siding. And if you were to cut through that, take a chainsaw and cut through it, pull it apart, and use it like a rubber stamp on it, put it on an ink pad and stick it on a piece of paper, what you get is similar to the drawing on the right. That just has a overhang there. It's just for decorative reasons. But the one on the top is a wood siding, and the one on the bottom is cement board siding. Cement board is more durable. It's made out of Portland cement and formed into a board and then put up, and you can paint it. Sometimes they texturize it so it doesn't look flat. It looks like wood. It's much more durable, obviously, since it's made out of Portland cement. Brick, as we just talked about, is another thing that you can do. That definitely increases your R value. Brick is very low maintenance. In fact, it was a requirement for me when I bought my house. It had to be brick. I was uninterested in anything that was not brick on all sides. So I had to buy an older house to be able to afford it because brick's expensive, as I've said. And then here's some sections, which you can see when you're building through the wall or cutting through the wall, right? We got our foundation down here on both sides where you can see the foundation, and you can see the brick, and you can see the sill plate and the joist, and all this is and then of course the studs coming up on both sides. You can see that. You see the insulation. Here they use plywood. In the South, we use plywood over the wood studs to create a diaphragm. And that diaphragm keeps the walls from collapsing. It gives them a structure. And then over that, they have some tar paper that they've used. And then you can see in the wall something called a metal tie. So for every 1, 2, 3, 4 or so, you can go higher. It just depends on what does it depend on? That's a good question. I don't actually know. I believe there's supposed to be 24 inches between brick ties. Structurally, that's the way to go. So so you would have to count up the size of the brick. Okay, so that's what it is. So the brick ties go 24 inches apart up the wall, and they just they keep the brick attached to the wall as it goes up. Because you can see when something narrow like that gets stacked up on top of itself, eventually it's going to fall over. So we have to put those brick ties in there, 24 inches on center, both up and down and this way, across the wall and up the wall. We also have to drill weep holes, 24 inches on center. So you just drill those at the same place that you put the brick ties. And those allow any of the dew that has fallen inside the wall on either the back of the brick or the over the tar paper. It's going to allow it to come down, wick down, and then drain out. Because if water continues to build in here and then it freezes, you're gonna crack your brick, and get structural damage. So that's why we do that. This actually has a nice plastic mesh down in here, and that helps to deal with when they're putting the brick in. It helps to deal with any of the mortar droppings so that they don't plug up those weep holes. Also, be considerate of masons who are laying the brick. You see there's that cavity between the wall and the brick, airspace. We usually give it about 1 inch. And that is so that when they're laying the brick, they can put the brick in place with their fingers not hitting the wall. I don't know if you guys have ever known a brick mason, but sometimes they have some pretty gnarled looking joints on their fingers from putting brick and hitting their fingers. So by leaving them that 1 inch air gap, gives them enough space to get their fingers around that. And so they will, as you saw in the image before, right? He's got a string along here, knowing how where they should go as they go up, and you can see him putting the grout, the mortar down, and then the brick. And so this is what those wall sections look like through that construction. Stucco is another possibility. Stucco is expensive. They came out with a product called, it's had many names over the years, but Exterior Insulation of Finish System, EIFS, or EIFS, or IFS. I've heard it pronounced multiple different ways. And it's basically board that has a fake stucco finish on the outside of it. And it's easier, faster, but it grows mold. So it has to be regularly cleaned. But original stucco, which is pretty common in Western climates where mold doesn't grow on the side of buildings as much as it does here because they don't get as much rain, stucco is another material. You can also transition between materials. And this is just showing you that whenever you transition between one material and the other, there has to be some way of making sure that the material above is recessed behind the material below, so that when rain runs down the face of the material above, it's going to hit some sort of in this case, there's a brick ledge right there. It's going to hit the brick ledge and drip off. And then you can just see this is an example on the right of how stucco is put together, right? It's got a layer of insulation, usually foam, and then it's got another layer of lath, and then on top of it, it's got another lath. Get those words backwards. Lathe is when you put a piece of wood on a spindle and spin it. Or other material, but it's usually wood. Lath. And then you start putting scratch coats. So you can see you've got a lot of work behind stucco, which labor is very expensive and it drives up the cost of doing things. Okay, I'm going to stop here, and in the next video we'll start talking about roofs.